Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 738, monotone increasing digits. This problem tells us that we're given an integer which has which holds an integer, has monotone increasing digits if and only if each pair of adjacent digits x and y satisfy this condition, x is less than or equal to y. And we're given an integer n, and we want to return the largest number that is less than or equal to n with monotone increasing digits. So let's look at an example. Here we have n is equal to 10. Well, does this satisfy the condition? Let's say 1 is x and 0 is y. Does this satisfy the condition where x is less than or equal to y? No, it does not. So we return we don't return 10. We decrement 10 to 9, and we return 9. Right. So that's the result that we return. So let's look at another example. Another example is 1, 2, 3, and 4. So we say, what is this in monotone increasing? Does this have monotone increasing digits? Yes, it does. So we just return the number itself, 1, 2, 3, 4. In this example over here, well, we have 3, 3, 2. Now let's walk through it because we returned 299. Why did we do that? Well, 3, 3, 2. Does this satisfy the condition for each of these digits? No, it does not. So what we do is we say, let's decrement new to 331. Does it satisfy any conditions? No, it does not. 330, still no. 299, well, yes, it does. It satisfies the condition that we want to satisfy, that each, that all the digits are in monotone increasing order. So we return 299. And so you can probably tell by this there will always be an answer because we'll just keep decrementing until we find an answer. And no matter the number, it might take quite a while, but eventually, inevitably, we will get to an answer. So, how would we solve this kind of problem? Well, this is kind of where the intuition to solve this comes in, but really we want to have a greedy approach. Okay, so let's take this example 332. Well, we want to look for a conflict, and a conflict is where this condition is not satisfied. So, well, are the conditions satisfied for 3 and 3? Well, yes. So we say, okay, we can go to the next 3. What about 3 and 2? Well, no, they don't satisfy. They don't satisfy this condition where x is less than or equal to y. So what do we do? Well, we decrement 3. We decrement 3 into a 2, and we convert all the rest of those numbers to 9. Because remember, we don't want to just keep decrementing. We still want to have a large number because we want to have one less than the number that it was. We don't want to decrement like tenfold. We just want to decrement a single digit each time. So here we have 329. And what do we do? Well, let's go for another pass and see are all the digits in monotone increasing order. Well, 3 and 2, well, no, they don't. X is not less than or equal to 9, so we decrement this 2 now. So we decrement this 2 into this 3 into a 2. We compare, 2 and 2, or 2 and 2 in monotone increasing, or monotone increasing digits. Well, yes, because although they're both equal to each other, they still satisfy the condition. So we have 2, 2, and then we have 9, which we know satisfies the condition. So basically, we come at a conclusion, which is 229. Well, of course, our program is going to do another pass because although we can see this, our code cannot. So we'll do another pass, and we'll say, are there any other changes that we need to make? No, there's not. So therefore, this is the correct answer. So I hope that explanation made sense. Let's get straight into coding this. So the first thing we want to do, of course, when we're working with a problem like this, is we want to convert these digits into a list so that it's easy to work with. So the first thing we can do is convert each string into each character so basically convert the entire integer into a string, and then convert each character in this string into an integer, and map will return an iterator. So we're just going to convert this into a list, and then we want to also get the length of our number of digits. So this is just so for brevity's sake, when we carry on writing the code, it'll make more sense why we do that, just basically to prevent a duplicate code. So the next thing we want to do is say while change. So changes are going to be equal to true, and this is going to be if there's any changes that we need to make. If we make any changes, we set this equal to true. If it's equal to false, well then that means we've made no changes, and therefore we have derived an answer. So we're going to say while changed. Well, we'll set change initially equal to false, and our job is to make this true if need be. So we're going to say for in range, and we can just say length, but we don't need to say length. We can start from one more than length, and the reason we do this is simply because we want to be able to convert. We want to be able to be at y and then look at x. It just prevents us from having to check if we're in or out of bounds. So we're going to say if digits I is less than or equal to digits I minus 1. That's I minus 1. Okay, so we'll set digits I minus 1 equal to 1. Minus equal to 1. Actually, no. We'll set digits I minus equals to 1 because we want to decrement the current number. Actually, now that I think about it, no. We'll actually convert this the number beforehand, so because we are going to be at y, right? And x is the number here, so we've already added x, and now we're checking the condition. So we want to convert the previous number x. So that's going to be I minus 1. So yeah, no, that is initially correct what I wrote, I minus 1, and then we want to convert all the rest of the numbers. So for j in range of I, and this is where our length variable comes handy, we want to set digits I equal, digits j equal to 9. So we're going to say digits j is going to be equal to 9. So we convert the rest of the characters to 9, and then we set changed equal to true, right? So we set changed equals to true, and then we can break out from this for loop, and we can go to the next pass. And then once our while loop is finished, it means that we found an answer. So this is where it gets a bit confusing. What do we have? Well, we have this can catch you up in an interview because you have now a list of digits. But what we can do is convert this list of digits into a list of characters, so into a list of strings. So we're going to say let's pass in digits. So let's pass in digits, but this now returns a map. So we want to convert this, we want to join this into a string. So join into a string, but that's still not enough. We want to now convert this into an integer so that we can return it, because that is what we need to return. We want to return an integer and not a string. You can see the return type there. So yeah, let's run the code. Let's submit the code, check it works. And we get the wrong answer. Why do we get the wrong answer? Let's look through the code. So 289 instead of 299. Okay, so this is the problem over here. It should be the opposite. So the opposite of or was it less than? Let's look at the condition over here. Less than or equal to y. Should just be less than digits I, right? That would be what does not satisfy the condition. So let's check the code works. And now we pass all 308 test cases. So basically that problem over there was that we have, if we are from y's position, we should be greater than or equal to x. The opposite of that is less than. So if it's less than x, then we're not satisfying the condition, and then we need to decrement the previous digit. So I hope that made sense. We did submit the code and we get an optimal solution. In terms of time complexity for this problem, it's going to be big O of n for both time and for space. So with that being said, guys, I hope you enjoyed this video and it made sense, and I'll catch you in the next one.